Hello, this is Callan Bentley. Welcome back for another Smart Figure. In this video, we're going to take a look at the concept of sedimentary facies. And after watching the video, you should be able to describe what that concept is and how it can be applied to interpreting sedimentary rocks. Here's a scene in the American West. This is Monument Valley. You can see here there are several different packages of sedimentary rock, a very prominent cliff-forming unit, some more layered rocks on top of that, and underneath the cliff-forming unit also some layered rocks. One of the challenges that sedimentary geologists have is how to interpret sequences of rocks like this. One of the guiding principles is the facies concept, and the idea here is that different kinds of sediment can be deposited in different places at the same time. So in other words, if you were to go down to the beach today and you were to examine the type of sediment there at the beach, you would find that it's perhaps sand. If, however, you were to swim offshore some distance, you would leave the sandy bottom and you'd be out over mud. And that mud, of course, when compressed into a sedimentary rock, becomes shale. And if you swam far enough offshore, perhaps you would find yourself far away from the sedimentary influence of the land. No more particles are making it that far out into the water. And so the only sediment that's being deposited there would be chemical sedimentary rocks derived from ions that are dissolved in the seawater. So you'll notice that this is a sequence, basically, that you've got sandstone closest to shore, then shale, and then limestone. So basically the sand is the largest particle there. The shale is made out of clay particles, so those are smaller. And then the limestone is actually made out of ions that were dissolved in the seawater. So basically you've got this sequence. If you were to add something to that sequence, perhaps it might be a conglomerate, which is made out of pebbles. That would be even more shoreward in this sequence. And as you head away from the shore, the pattern is that the sedimentary particle size gets smaller and eventually it runs out completely. In a real offshore environment, perhaps you would end up finding ooids. These are these little chemically precipitated grains that are spheres or close to spheres. Basically, they're getting washed around and then new layers of calcite are being added on the outside just by precipitation from the seawater. So you've got this sequence of sedimentary types that will be preserved in the geologic record as rock types. And each one is basically a neighbor to the others. Notice that they have sort of a gradational relationship here where one sedimentary type stops and then the other one picks up. It's gradational. It's not abrupt. So if you were, again, swimming from the shore out into progressively more and more offshore waters, you wouldn't see a line on the bottom of the ocean where suddenly the sand stops and the mud begins. It's more gradual than that. So this can be really useful to us because if we're mapping a geologic area and we find a sample of, say, sandstone, and that sandstone comes from this location, and then we go to another location and we find some oolitic limestone. Let's say we found that right here. Just for the sake of demonstration here, let's pretend these are exactly the same age. Well, that suggests that the limestone is in the more offshore position, whereas the sandstone would be deposited pretty close to the beach. A way you might test that hypothesis is to go over to another location, like say here, and see if you could find another rock from that same period. Let's see what we find if we go there. Ah, mud cracks. Okay. Now mud is a finer grain size than sand, but mud cracks help reinforce the idea that this location over here on the right is actually a location that's exposed to the air periodically, because you can't create mud cracks unless you dry out the sediment periodically. So that's something that would be consistent with being above sea level. So perhaps a very crude interpretation of this area at the time these sediments were deposited would be something like this. It's land over here on the right, and then over here on the left, that would have been sea at this time. And the sandstone sort of marks the transition between those. The oolitic limestone could only form far away from the land, and the mud cracks would only form when you've got water that's shallow enough to be exposed to the air. You get it? Good. I hope you got it. Thanks very much for your attention. This has been another Smart Figure.